Okay, so last time we were looking at a basic sketch that would draw an ellipse and it would follow your mouse around. So this time we're going to get into how to create an actual bouncing ball that's going to move around on the screen on its own, hopefully change its colors based on where it is on the screen, and all that. So let's get into it. So we were previously using mouse X and mouse Y to tell processing where to draw the ellipse, right? But if we wanted that to move on its own, we could create variables that would represent its position instead, and then we could just change those variables over time by a certain velocity, right? And then it would be moving around. So let's create just two floats, which just means that it's a decimal number, and that's going to represent where the ball actually is in the window. So we'll just create float x and y, and then in setup, which only runs once, remember, we're going to tell it what x should start as and what y should start as. So arbitrarily I can just say x is 200, and I'll put y at 200 also. So we're just going to starting x and y position. And so instead of drawing the ellipse at mouse x and mouse y every frame, we're going to draw it at x and y. And then all we'll have to do is change what the values of x and y are over time, and the ball will move, right? So we're going to just kind of draw it at x and y. And if we run this, you'll notice that nothing really changes, which makes sense, since we created variables x and y, but we didn't actually change them over time, right? So if we're going to change them, right, we're changing the position of the ball over time. That's called the velocity, right? It's the positional velocity. So we can create two other floats that represent the velocity in the x and the y direction. So we can just say vel x and vel y are our variables. And just like x and y, we're going to have to initialize them as something. We're going to have to tell processing what to start vel x and vel y as. So arbitrarily, I'll just say vel x will be 5 pixels in the right direction, and vel y can be, let's just say, 3 pixels. Let's see how that works. Start off velocity, and okay. So we're still not going to be changing x and y. We're going to need to actually modify the value of x and y, right? So here in draw, which is going to happen every time a frame is drawn, we can change the value of x by the x velocity. So all we need to say is x equals what it currently is, x, plus the x velocity, right? And we can do the same thing for y. Y equals y plus vel y. So this will move the ball by its velocity. And that's going to happen every frame. So if we draw that, what we should see is the ball start to actually move. And there he is. He's going off the screen. And I'm just going to remove this background real quick so it leaves a trail, which just might be easier to see. Draw the ball back. So let's see that. Right, so now the ball is moving over 5 each frame and down 3 each frame. Remember, because positive y actually moves down on the screen in processing. So this is great, and that's the beginning of the bouncing ball. But the only problem is that he keeps going off the side of the screen, and we want him to bounce around in the window, right? So we need to tell it when it should turn around, right? So there are two things to think about there. One is, where do we need to actually turn around? And two is, what does turning around even mean in this context, right? So if we're moving 5 pixels to the right and 3 pixels down, and we encounter a boundary like this that we want to bounce off of, what does that actually mean? Well, if our velocity is going 5 pixels to the right, it means we want to completely reverse it so that now it's going 5 pixels to the left. And that would mean going from positive 5 to negative 5, because negative 5 will move us that way, right? So bouncing off the wall really just means multiplying the velocity by -1. So that's how we're going to achieve that. Now let's think about when we need to do that. If you look at the window here, right, the point, like the horizontal boundary on the left is going to be when x equals 0. That's the smallest value of x. And on the right, that's going to be when x equals the width of the window, right? That's when we want it to bounce. Similarly for y, at the top it's going to be y equals 0 when we want to bounce off the top wall, and y equals height when we want to bounce off the bottom. So what we can do here is come down here in our draw loop, and right after we've moved the ball, right, using the vel x and vel y, we can check to see if the ball is going off the screen. So like I just said, if x is going to be less than 0, right, that means x will be coming off the left side of the screen, so we want to flip it around. And same thing if x is greater than the width of the window. And this width variable just gives us the width, which is really nice, so we don't have to hard code it in every time. And that, you'll notice those 2 pipes there, that just means OR. That's how we say OR in processing. So if x is less than 0, or if it's greater than the width, we know we want to turn the ball around, which, like I said earlier, just means multiplying the velocity by -1. So if that's true, what we're going to do is come in here and say vel x, right, equals itself just times -1. And that'll just flip it around, and it should bounce the ball off the side. So we can go ahead and test that, right? So if an x boundary encountered bounce. So we can test that by running it and see what happens on the sidewalls. So it deflects off, which looks like it's good, and then it just kept going past because we haven't set up the y. But the y is really basically the same thing, so we can just copy this, right? Paste it down here. If a y boundary encountered, so this is going to be if y is less than 0, that's the same thing. That just means it's going off the top of the screen. Or if y is greater than the height of the screen, right? Which would be down here. Then we're going to say vel y equals itself times -1. So that should flip the ball around and it should look like a bounce. So let's test that. Nice, so it looks like it's bouncing, and that's basically it for the bouncing ball. It's doing everything it needs to do, it's drawing itself, it's moving by a velocity, and it's bouncing off the boundaries as it encounters them. So this is a really good starting sketch. There are a lot of improvements you can make for sure, like the colors, how does it look, how does it bounce off the wall, does it like randomize when it bounces off? There are a bunch of expansions, also like the size of the ball. You might make it interactive, it could depend on like where the user's mouse is, could change the size of the ball or the velocity. There are definitely a lot of really cool extensions. In the next video we can get into stylizing this a bit more and changing the colors and doing some scaling of the position to change the color so it looks a bit cooler. But this is a great start, so thank you.